Yeah, good day all. Let's look at an example under interpolation method. So our question says form a difference table and interpolate the value of f of x when x is equal to 4, given that x is 3 when f of x is 180, x is 5 when f of x is 150, x is 7 when f of x is 120, and x is 9 when f of x is what? 90. Now they want us to find the value of f of x when x is what? 4. Now as we can see, that value will fall in between this. Yeah, 4 lies in between this. So therefore, we are going to be using Newton's forward method. I almost forgot this name. Newton's what? Forward method. Now, its formula for solving your Newton's forward method. Remember, we are using Newton's forward method because our 4 lies in between 3 and what? 5. If it was in between 7 and 9, we'll be using Newton's what? Backward method. And another thing again that we didn't actually consider, if we're going to be using either Newton or Lagrangian, is that our interval, we didn't talk about it. If you notice, do we have equal interval? Let us check. So we are going to be having 5 minus 3 and 7 minus 5 and 9 minus 7. Are all these equal? Going to be giving us equal thing. Now 5 minus 3 is what? 2. 7 minus 5, 2. 9 minus. Okay. So these are satisfied all the requirements needed to be using Newton's forward method. Another way you can know that they are referring to Newton's forward method is from the question. It says form a difference table. It is only in Newton's method that we make use of what? Difference table. We don't make use of it in Lagrangians and in binomials method. It's only in Newton's forward and backward method. That is only when we make use of the difference table. So with that being said, let us dive into what we came to do. Now we are asked to get x. We're going to ask to get y when x is, or f of x, whatever you choose to call it, when x is what? 4. Okay. Now our formula is our f of x, whatever we choose to call it, that we are looking for, is going to be our first value of f of x. I would prefer to call it here y. So one changes I'm making is correcting this, changing this, not correcting. It's actually the same thing. So I'm changing this to be what? Y. So this step I took now is not compulsory. If you are good with working with your f of x, good and fine. But I just want to make my writing not to be too bogus, if possible. Okay, let's try. So y is equal to our first value of y, which is our 180. We'll write it down using our first value. This is the formula, first value. Then we add it to u over what? 1 factorial. Very soon I will tell you guys what our u is, and we're multiplying it to the change in what? Our y. Now this change in y, we'll be getting it from our what? Difference table. Then we'll add it to another u, but this time around we'll be multiplying it by what? U minus 1 over what? 2 factorial multiplied by the change in y. But this time around, our change will now be the second change. Talking about the second change. This will be fully explained when we are doing our difference table. And again, I think the order it follows is that while you keep on multiplying by your u minus something plus 1, maybe is your the value is increasing. I will say that here we are subtracting from u minus 0, next one u minus 1, u minus 2. So when we as we are increasing in the number of u's value we're having here, so also will our factorial keep on increasing. Our factorial normally is to be the same number of multiple. Like here we have 3 multiples, so 3 factorial, then we still multiply it to the third change in what? Y. Now, are we going to be stopping here or should we go for the fourth one? How do we know this? Now, how you know whether you're to find for the fourth difference and the rest of them is from the number of what value of x given to you. If the value of x given to you is 4, then the number you're going to be stopping at is what? 3 factorial. So in all essence, when you're to count the number of variables you're meant to be adding, or the numbers of constants you're meant to be adding when you fix your value, you're having, this is 1, whatever this value is, we add it to another 1, to another 1, to another 1. So if you notice, the total is what? 4. And also the total of your x given value here is what? 4. So that's why we are stopping at 4. But here we'll stop at what? 3. So we'll be doing minus 1. I hope this doesn't get you confused. But if you don't grab it, and I'm just trying to explain why we are stopping here, we're not going for the fourth one. We are stopping here because of what? The number of our x given value is what? 4. And we have 1, 2, 3, 4. Shouldn't be more than 4. Shouldn't be less than 4. So when you're solving and you are counting it and the number of things you're meant to add are not adding up, or they're not up to the number of x known values, there's a mistake somewhere, so you have to find it. That's all I'm trying to say. So since we have gotten our value, let us make more emphasis on what u and what change in y is. Now we know that the y here, this y0, is our first value of y. First value of y in this case, which is what? 180. Now our u is equal to the x value that we are asked to find, whatever you choose to call it, I don't know. Then you subtract it from the first value of x. In this case, the value we are asked to find is what? 4. And our first value of x is what? 3. So you subtract that value from the first value given to you, of x given to you, all over the interval between each of the value, each of the x value. So where you saw us when we are doing 3 minus 5 and 7 minus 5, sorry, this is 5 minus 3, 7 minus 5, and 9 minus 7. All this is giving us what? 2. So our h is what? 2. Our h is what? 2. That's for the u. Now for us to get our y, the change in y, we need a difference table. But first, let us get what our 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 u is, but first let's say this our y0 is what? 180. We know this. Now for our u, the value we are asked to find is what? 4. And we will be subtracting it from what? The first value of x, which is what? 3. Which is what? 3. And we'll be defining it by our what? Interval. And when we do that, we have 1 over 2, which is also nothing as 0. What? 5. So our u in this case is what? 0.5. So we'll be writing down and we'll be writing it here. So our u is what? 0.5. Now let's get our change in y values. Now how we do this, we represent this that is initially given to you horizontally. We will now make it now to be vertical. We'll be having our x and our y here being 3, 5, 7, 9. What we are trying to do is the difference table, we are trying to get it. And our corresponding y value will be 180, 150, 120, and what? 90. So we have this. Now we'll be getting the what? First difference. Now the difference is typically, our first difference is just this minus this. The down one minus the up one. Not the up one minus the down one. Don't make that mistake. It is the down one minus the up one. The down minus the up. The down minus the up. The down minus the up. So we'll be subtracting 150 from 180 to get a particular value. Subtracting 120 from 150 to get a particular value. And 90 from 120 to get another particular value. So for our 180, for the first one, 150 minus 180 will giving us what? Minus 30. 120 minus 150 what? Minus 30. And 90 minus 120 will giving us what? Minus 30. So as you can see, as we keep going, our value keeps on reducing. Like instance, we have 4 values here, but our change is now reduced to what? 3, which is just the difference between this and this, this and this, this and this. So we have gotten that. Moving over to the second difference, the second change in y, we're going to be having 30 minus 30 minus 30, which will definitely give us what? Minus 30 minus minus 30, which is written as minus 30 plus 30, which is what? 0. Minus 30 minus minus 30 is written as what? 30 minus 30 plus 30, which is giving us what? 0. Now that is for our what? Our second change in y. Now for the last change in y, to be this minus this, which is definitely what? 0. So remember, when you want to subtract or you want to get your difference table, you subtract the one below from the one above, and not the one above from the one below. Don't make that mistake. So we have gotten our difference table. Now the crucial or the values we are going to be making use of will be the first values we got from the table. These are the values we are going to be making use of, and we'll be neglecting the rest. This is true whether your values here are equal or not. In cases where maybe the difference between all these are not equal, like like the one we are solving now, we still select the one that is on top. Doesn't change. So we keep selecting this particular what? Values. That's what we are going to be making use of. So let's write down the values of our change in y. Change in y, we have it to be what? Minus 30. And second change in y, we have it to be what? 0. And the third change in y, we have it to be what? 0. Oh God, forgive my handwriting. So we have gotten all this. So let's implement it in our formula and get our answer as quickly as we can. Okay, so let's go. So for our y, the first y value is what? 180, like we said. Now we will add this to our u being what? 0.5 over 1 factorial, and multiply it to our first change in y being what? Minus 30, plus our u being what? 0.5 multiplied by 0.5 minus 1 divided by what? 2 factorial, then multiplied by our second change in y, which is what? 0. Yeah, definitely everything here will give us 0. The next one, 0.5 multiplied by 0.5 minus 1. Then multiply by 0.5 minus 2 over 3. Oh, God has punished me. Why will I write this 0? Okay. There's a 0 there, you know. Sure, you know. You know, Nabi. So there's a 0 here, multiplying everything. So when we open our bracket, definitely here is gone. Here is gone. And here is also gone. This is 0, 0. Reason, your 0 is multiplying everything here. Your 0 is multiplying everything here. Now, these are the members. Let us focus on them. So our y is equal to 180 plus. Now, 1 factorial is also the same thing as what? 1. When we say factorial, if you're asked to get 2 factorial, 3 factorial, 4 factorial, it's quite easy. This is 2 times 1. This is 3 times 2 times 1. And this is 4 times 3 times 2 times 1, which is just the multiple of the consecutive numbers that came before the number you are asked to find is factorial. If they decay too much, it's just simply multiplying a particular value, the numbers that came before it, you just multiply them all through. So this will be giving us what? 2, this is what? 6, and this is what? 24. And for 1 factorial is just what? 1. So we have 1 factorial here, so we are having what? Over what? 1. Now 1.5 times minus 30 will give us what? Minus 15. This is half times 30. So half of 30 is what? 15. So we'll be having this. We're having this. Okay? You can also write this as 180 minus 15. Because minus times plus is what? Minus. And when we subtract, we'll be having 165 as the value of y when x is 4. Kai! So that's all for the video. It was fun. Maths is fun. Believe it. See you in the next video. Please subscribe to the channel. Smash the like button if this was helpful. Goodbye.